Hey guys, welcome back. If you watched any of our videos on transformers, you may have noticed this strange crossarm floating around in some of the photos. Let's talk about what all of that stuff is and what that equipment does. This is called the fuse cutout. It's comprised of a corrosion-resistant steel frame along with a ceramic or polymer insulator. The insulator electrically isolates a steel mounting tab from the frame. The mounting tab allows the cutout to be attached to a wood or fiberglass crossarm using a steel rectangular mounting bracket that's attached to the crossarm. The entire purpose of the cutout is to hold a high voltage fuse. The tube assembly shown at the right is a fuse holder. The actual fuse element is located inside the holder. The fuse holder is then attached to the cutout by a line worker. The cutout is typically connected to a primary phase conductor with a crimp or a wedge connector and a lead wire. The bottom of the cutout is connected to the primary bushing of the transformer with a second lead wire. In the event of a fault on the transformer side of the cutout, the excess current caused by the fault will cause the fuse element to melt. This will open the electrical connection and de-energize the transformer. This usually happens with a loud pop, which will cause the fuse holder to kick itself off of the cutout. The fuse holder, now hanging in the upside-down position, aids the line worker by providing a visual cue regarding the location of the fault so they can begin the process of restoring the now de-energized service. Let's take a look at that one more time, a little slower. You'll notice that when the fuse element blows, sparks of molten copper and other metals are ejected from the fuse holder. This is pretty common with some of the older fuse holders. These sparks also have the potential to land on the ground and start a fire. For that reason, some utilities engage in a practice called pole brushing, where they clear the vegetation away from the base of the pole where the sparks might land. They also utilize newer fuse holders that are able to suppress the sparks and prevent them from leaving the fuse holder altogether. Here's a picture of an older cutout with a ceramic insulator. You can also see the fuse holder and the crossarm mounting bracket. The upper lead to the overhead phase conductor is attached with a crimp connector, and the lower lead to the transformer bushing is shown here. Here's a newer cutout with a silicone or polymer insulator. Some utilities cover the cutout with a protective cover meant to protect birds if they should land near the energized conductors. You can see that cover right here. The crossarm mounting bracket is shown here. The upper lead is attached to the primary phase conductor with a wedge connector, a stirrup, and what's called a hotline clamp. The lower lead is shown at the bottom, connecting to the transformer bushing. Pretty cool, huh? Let's talk about this thing now. This is a lightning arrestor. It's actually a variable resistor, sometimes called a varistor, if you're into that sort of thing. This thing actually works like a switch. When a normal operating voltage between a phase and ground is placed across the top and bottom, it acts like an open switch and doesn't let any current through. However, when a lightning strike hits one of the phase conductors, crazy high voltages of hundreds of millions of volts can travel through the conductors. This energy needs to be offloaded from the system before it can cause any damage or injury. When this happens, the varistor senses the extremely high voltage and instantly acts like a closed switch and lets the energy pass through to ground. When the voltage returns to normal, it instantly returns to its open switch state. In areas where lightning strikes are known to occur, these get installed on the other side of the same crossarm mounting bracket used to attach the cutout. It's connected by using a crimp connector and a short jumper wire, usually attached to the same lead wire attached to the cutout. A ground wire is attached to the bottom of the arrestor and attached to the underside of the crossarm and down the pole to a ground rod. If this is a steel pole, the ground wire will be attached to the steel pole near the crossarm with a split bolt. You can see the lightning arrestor here. The jumper wire connected to the top of the arrestor is attached to the same lead wire that's connected to the top of the cutout using a hotline clamp. The lower ground wire is attached to the bottom of the crossarm, and since this is a steel pole, the ground wire is attached to the pole using a split bolt. Here's a photo of both protection devices, the cutout and the fuse holder, along with the avian protection cover, the cutout's lead wire connected to the main distribution conductor. Over here we see the lightning arrestor. This one is connected to the distribution conductor separately. The cutout and fuse protect personnel and equipment from overcurrent problems that occur on this side of the system, while the lightning arrestor protects from overcurrent issues happening on this side. Pretty cool, huh? Thanks for watching.